Well, hello. So, in this example today, we're talking about angles, specifically finding the measure of angle BEC. So first things first, that's what this stands for here. The M with the angle sign, BEC, stands for the measure of angle BEC. So that's what that little M stands for in the front. If we just wanted to talk about an angle BEC, we just write like that. Now, to talk about defining an angle, unlike a line segment or something else, an angle is something that's about direction. And so, since we don't care about distance, what we're actually working with our examples down below are a series of rays. EA is a ray, EB is a ray, EC is a ray, and ED is a ray. So they're all arrows going off, and so an angle happens when two rays meet at one point. That one point we call a vertex. And so E is our vertex. And the vertex, by almost an ironic name, is defined as where the two rays meet. And so a vertex more generally means center. And so an angle is when two rays meet at a vertex, and the vertex means center. And so we're looking to find angle BEC. As I said a second ago, there's a couple of ways to do that. One of them is to think about what it means to be congruent. And so congruent, we'll talk a lot about congruence as the year goes on. For this example, for our understanding, congruent just means same. And so, in order to determine if things are the same, in order to do any of this, we first need to know how to read a protractor. So if you'll notice on this protractor, and often on the protractors that you'll be using in school, you'll see two rows of numbers. If we look at the vertex AE here at the bottom, notice that lines up with the 0 here. And notice that the other 0 does not have a line on it. It is not part of our angle. So if we try to read from this protractor, we're reading from the 0, and then we want to read up along that protractor. And so reading from the 0, where the line goes through it over here by AE, we're going to be reading the outside as we go across to determine the size of our angle until we reach the end. So this angle AEB has a measure of 50 degrees. It is not 130 because we're not reading from the 0. So we could do that the same thing from the 50 to 100, and with some mental math, we can tell that that's also 50 degrees. And so the measure of angle BEC is also 50 degrees. Because they're the same, we can say that these two angles are congruent, and we're able to notate that. We're able to show that by putting a dash mark in each. If we put a different number of dash marks, as long as they matched, we'd know that they were congruent. So if I put 2 dash marks in, I'd have to put 2 dash marks in the others, because that shows that they're the same size, that they're congruent angles. And so that's one way to find it. The other way is using some subtraction. So in case the numbers aren't as easy, or it's not as simple to count, or in this other case, you might be using equations like you saw with our segment addition. So knowing how to use equations with this is just as important as being able to count. And so let's talk about using those equations then. So in order to use our equations, what we're really identifying is that we want to do some subtraction to find the size of our angle, to find the measure of our angle. And so what we're really looking for then is the difference, and difference means subtraction. So we want to know the difference between AEC, so we want to know the measure of AEC minus the measure of AEB. By taking the difference of those measurements, we're going to find the difference between those, which is the measure of BEC. And so we know, because we're able to count, that AEB is our 50 degrees. And so we counted that. The measure of AEB is our 50 degrees. The measure of AEC, if we read that whole thing all the way across, is 100. And so we take 100 degrees, subtract the 50 degrees, and we're able to find the measure of our angle, BEC, is equal to 50 degrees. Perfect. Now I do want to cover a couple of last topics and ideas here, and that is how we name angles. Angles are always named by 3 letters, and the middle letter will always be the vertex. And so when we want to talk about, and that's kind of why I left this last angle over here to be able to talk about this. So if I want to talk about this angle, first, our vertex is E. That's always going to be the middle letter. And then essentially you can think about naming it as you draw it. So if I start from one of the sides and I want to draw it without lifting my pen, I'm going to go from D to E to C. And so because I drew it like that, I can call this angle DEC. Or I could have gone the other way, right? So I could have gone from, and I'll go, let's see here, I'll use pink for this one. So I'll start with C, and I could go from C to E to D. And those are the same, well, that's not how you write an E. Ooh, that's also not how you undo things. There we go, C, E, D. So even though the letters are slightly out of order, they are the same angle because the rays are the same and the vertex is the same. If I switched the order of the letters anymore, if E wasn't in the middle, then we're not talking about the same angle. So let's go ahead and use this nice light green color to help illustrate. Let's say I wanted to draw angle EDC. Then I have to start at E. I have to go to D. And then I go to C. And if you notice, that is not the same angle as the ones we were looking at. D is our vertex, not E. So it's a completely different angle. It's not one that we know the measure to because we're not looking at the triangle, or not, we're not looking at the angle that had E as our vertex. And so that does not work to name the angle CED. Now, other than that, there's only one last thing I need to kind of quickly debrief, and it is the difference between acute and obtuse angles. An acute angle is small. It's acute angle. It's less than 90 degrees. And so here, I'll just move my face over into this corner over here. So acute is an angle less than 90 degrees. An obtuse angle is an angle that's larger than 90 degrees. And there's one last angle that's kind of new and kind of fun, and that's called a straight angle. And a straight angle is a straight line. It just means 180. And we can kind of show that off here on our work. So if we go from E, and I kind of finish this line all the way over here off to the side, to go from AE all the way over to the other side here, you get 180 degrees. And that's a straight angle. A straight angle is just a straight line. And so, I hope that clears a few things up. Hope that answers a few questions. The only last thing that I want to be able to say and point out was a vocabulary word that I missed in the last video that I did talking about adding line segments, and that is collinear. If you have things that are collinear, it means same line. You see this applied most often to points. You could say points that are collinear. It means that there are 3 points that are all on the same line. In this example, which has lots of colors and lots of fun lines on it, none of the points are collinear, except for AE, and then a third point that we can add over here. And so we'll go ahead and call this one, I don't know, Z. Z is a fun letter. So A, E, and Z are all collinear. And we really only talk about things that are collinear when there's 3 or more. Because otherwise, it's just calling it the name of a line, and a line will always have 2 points on it to be able to name it by. And so collinear is 3 or more points that are on the same line. That's a lot of information. I hope that helps. Don't hesitate to email me if you have any questions.